Namaste children. Till now we have discussed about work. What is work? The concept of work according to physics. Positive work, negative work and zero work. SI unit of work done and mathematically what is work done and the definition of work. Now today we are going to discuss about the energy. What is energy? For example, if two children are there, person A and person B. Suppose person A is more energetic than person B. That is the meaning of this statement is A can do more work than the person B. Same way, if after doing a lot of work, we will get tired and after that, we are not able to do much work. That a person doing work expends something. This something is known as energy. That is, from his body something will be dissipated, usually in the form of the basic energy, that is heat energy. The energy spent by a person is equal to the work done by him. So human beings and animals get energy by eating food. So it may be, can say that anything which is capable of doing work has energy. For example, the steam pushes up the lid placed on the boiling water container. That means the steam has the ability or capacity to do work. The work done by the steam on the lid is equal to the energy of the steam. Coming to the definition of energy, the capacity of doing work by a body as a unit is joule. When we say that energy of a body is 1 joule, that means this body has the capacity to do 1 joule of work. The various forms of energy are heat energy, that is thermal energy, chemical energy, sound energy, electrical energy, nuclear energy, solar energy, kinetic energy, and potential energy. What is energy? The energy of an object is its capacity for doing work. The unit of energy is the same as that of work, that is joule. 1 joule is the energy required to do 1 joule of work. 1 joule is the energy required to do 1 joule of work. 1000 joules is equals to 1 kilojoule. There are different forms of energy. They are heat or thermal energy, light energy, electrical energy, chemical energy, potential energy, kinetic energy, nuclear energy, solar energy, etc. Coming to kinetic energy, the kinetic energy of a body is the energy possessed by the body due to its motion. That is, the energy possessed by a body by virtue of its motion is known as kinetic energy. For example, when a moving object, say a ball, hits another stationary object, a wooden block, then the wooden block is displaced from its position. It means the moving object has done on the stationary object some work. So moving object has energy which is known as kinetic energy. Some more examples. A moving bus or a car or a train has kinetic energy. Moving bullets have kinetic energy. Flowing water has kinetic energy. A moving ball has kinetic energy. In other words, we can say this: anything which moves has kinetic energy. A form of energy that a body in motion possesses is known as kinetic energy. A body at rest, will it possess any kinetic energy? Example, bullet shot out from pistol, helicopter flying at 120 kilometers per hour. What factor this kinetic energy depends upon? Kinetic energy depends upon the mass of a body and its velocity. The mass or velocity of a moving body is increased, kinetic energy also will increase. The mathematical formula, Kinetic energy is equals to half mv square. Kinetic energy is equals to half mv square. Its unit is joule. Unit is joule, same as work done. Work causes change in kinetic energy, so the units are the same. Units of kinetic energy are joule, but from the definition of kinetic energy, the units are also is equivalent to 1 joule is equals to 1 kg meter square per second square. Example, the kinetic energy possessed by an object of mass m and m moving with a uniform velocity v is equals to half mv square. For example, suppose a body possesses 15 kg mass is moving with a uniform velocity of 4 meters per second. What is the kinetic energy possessed by the object? So mass of the object given as 15 kg, velocity of the object is given as 4 meter per second square. By definition, mathematical formula, kinetic energy is equals to half mv square, that is half into 15 into 4 into 4, that is equals to 120 joules. Therefore, the kinetic energy of the object is 120 joules. Now, what is potential energy? Energy possessed by an object by its position is known as potential energy. Potential energy is the stored energy in an object due to its position. Gravitational potential energy depends upon the mass and the height of the object. So mathematically, potential energy is equals to mgh, mass effect potential energy. Given here are three objects at the same height. As mass decreases, potential energy also decreases, that is directly proportional. How does height affect potential energy? Potential energy increases as height increases. That is again potential energy is directly proportional to the height where it is placed, that is position where it is present. Now, when you are drawing a graph between potential energy and to its mass, you will get an uniform linear graph, the direct proportionality between potential energy to its mass. Same way, when you are drawing between height and potential energy, then also the graph shows a linear straight line graph, uniform graph, which shows that potential energy is directly proportional to the height also. Now, once again, the potential energy of an object is the energy possessed by the object due to its position or shape. Example, if a rubber band is stretched and then released it regains its original position. When the rubber band is stretched, energy is transferred to it and stored as potential energy. That is called as elastic potential energy. We wind the key of a toy, is it on the ground, it moves. So, when we wind the key of the car, energy is transferred to the spring inside and stored as potential energy. If we lift an object to a height and release it, it falls down. When the object is lifted, energy is transferred to it and stored potential energy. Now, potential energy of an object at a height. When an object is raised to a height, its energy increases because work done on it is against the gravity. The energy present in such an object is called as gravitational potential energy. If the mass of the object is m, raised to a height of h from the ground, the force required to raise the object is equal to the weight of the object, that is mg. Therefore, work done is equals to force into displacement. W is equals to mg into height, that is equals to mgh. Potential energy gained by the object mgh. For example, find the energy possessed by an object of 10 kg mass when it is at a height of 6 meters above the ground, given g is equals to 9.8 meters per second. Potential energy is equals to mgh. Mass of the object given is 10 into height displaced is 6 meters into gravity that is equals to 9.8, which is equivalent to 9.8 into 6 into 10, is equivalent to 588 joules. Examples of potential energy are: water stored in a dam has potential energy due to its position. A stone lying on the top of a hill or a mountain has potential energy due to its position. A stretched or compressed spring has potential energy due to its shape. When spring is stretched or compressed, work is done on it. This work done is stored as potential energy of the stretched or compressed spring. A wound spring of a watch has potential energy due to its shape. A stretched bow and arrow has potential energy due to its shape. What do you mean by transformation of energy? In one form can be converted into another form. This is known as transformation of energy. The conversion of energy from one form into another form is called as transformation of energy. When energy is converted from one form to into another form, the total energy is always remains same. That means energy can neither be created nor destroyed, which is known as law of conservation of energy. So the law of conservation of energy states that energy can only be converted from one form to another, but it can neither be created nor destroyed. The total energy before and after the transformation remains the same. For example, let an object be allowed to fall freely from a height. At the start, the potential energy is more. As it falls down, the potential energy changes into kinetic energy. The potential energy decreases and the kinetic energy increases. When the object is about to reach the ground, kinetic energy is the largest and the potential energy is the least. But the sum of the potential and kinetic energy is same at all points. So, potential energy plus kinetic energy is equals to constant. The sum of potential energy and kinetic energy is the total of mechanical energy. Once again, at a glance, work in energy. James Prescott Joule, who is the founder of thermodynamics, the first law of thermodynamics, which is also known as Joule's law of heating. James Watt is the founder of steam engine. Now, already we discussed that what is work? Work done by an oblique force, positive, zero and negative work done, energy, potential energy, kinetic energy, power, transformation of energy, law of conservation of energy. For that example, we are going to take simple pendulum. Now, according to physics, here in the first picture, a horse is pulling a cart. So, it does work. A man is climbing the stairs. So, he does the work. An engine of a moving vehicle does work. A body dropped from a height falls towards the earth indicates that the earth exerts a force of attraction called gravity on the body. So the gravitational force does work in pulling the body towards it. Now, work is said to be done scientifically when a force applied on a body produces motion in it. Work done in moving a body is equal to the product of force exerted on the body and the distance moved by the body in the direction of force, or work done in moving a body is equal to the product of force exerted on the body and the displacement of the body. Work done is equals to force into displacement. W is equals to Fs mathematically. Work is a scalar quantity. Work can be positive or zero or negative. Negative work does not mean it is a vector quantity. Work done by friction is negative as the displacement is opposite to the friction. As a unit of work is joule, the symbol is J. 1 joule is equals to 1 Newton meter. That is, 1 joule is the amount of work done when 1 Newton of force acting on a body produces in it a displacement of 1 meter. CGS unit of work is erg. 1 joule is equals to 10 to the power of 7 ergs. 1 erg is equals to 10 to the power of minus 7 joules. For work to be done, both force and displacement must be present in a body. If a force applied on a body does not produce displacement in the body, scientifically, work is not done. Examples of these: a man holding a book in his hands in a stationary position does not do any work since the weight of the book acting on him does not produce any displacement. A man trying to push a rigid and stationary wall does not do work since the force applied by him does not move the wall. Work done by an oblique force. Force F is resolved into two rectangular components. F sine theta acting in the vertical direction does not displace the body in the direction. Therefore, work done by the component F sine theta is 0. F cos theta acting in the horizontal direction displaces the body in that direction. Therefore, work done is equals to force into displacement. That is equals to W is equals to F cos theta into S or Fs cos theta. Positive, 0, negative work done. The work done is positive if the force acts on a body in the direction of its motion. W is equals to Fs cos theta. W is equals to F cos theta. W is equals to Fs since cos theta is equals to 1. The work done is 0 if the force acts on a body in the direction perpendicular to the motion. W is equals to Fs cos theta. W is equals to Fs cos 90 degrees. W is equals to 0 since cos 90 is equals to 0. The work done is negative if the acts on a body in the direction opposite to its motion. W is equals to Fs cos theta, that is equals to Fs cos 180 degrees. W is equals to minus Fs since cos 180 is equals to minus 1. Some example: work done by gravitational force on a satellite is 0 because the force acts perpendicular to the direction of motion of the satellite. Similarly, work done by the sun on the earth is when we throw a ball vertically upwards, the work done by our force is positive, whereas the work done by the gravitational force is negative since it acts in the direction opposite to the motion of the ball. When the ball falls back, the work done by the gravitational force is positive since it acts along the direction of motion of the ball. What is energy? Energy is ability to do the work, or the amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. Energy is a scalar quantity. SI unit of energy is joule. CGS unit is erg. 1 joule is equals to 10 to the power of 7 ergs, or 1 erg is equals to 10 to the power of minus 7 joules. Different forms of energy. The basic energy, the existing energy in the universe is mechanical energy, which is the sum of potential and kinetic energy. Heat energy, light energy, sound energy, chemical energy, electrical energy, magnetic energy, and nuclear energy are the forms of energies. Potential energy. Potential energy is defined as the energy of a body due to its position or change in shape. For example, the raised hammer possesses potential energy. Work done driving the nail into the wooden block is done by the hammer. Its energy has released. The water stored in overhead tank possesses potential energy. Water, when released, is made to flow. Work done by this potential energy. Potential energy is stored in a compressed spring. When the spring is released, the potential energy stored in the spring does work on the ball and the ball starts moving. Energy is stored in a stretched catapult. When released, it does the work of firing the stone. Formula for potential energy. Suppose a body of mass m is raised to a height h above the surface of the earth against the acceleration due to gravity g. The work done in lifting the body against the force of gravity is given by work done is equals to force into displacement. W is equals to mg into h, that is equals to mgh. This work done is stored in the body in the form of potential energy. Therefore, potential energy Pe is equals to mgh. Potential energy is a scalar quantity, but it is to be taken with proper positive or negative sign depending on whether work is done against the force or by the force. Now, potential energy is path independent. That is, it depends on the net vertical displacement, that is height of the body, but not on the path through which it is raised. Potential energy in a round trip, that is over a closed circular path, is 0. P gained by the body is equals to plus mgh, whereas potential energy lost by the body is equals to negative mgh. So total potential energy in the round trip is equals to plus mgh minus mgh, which is equivalent to 0. Therefore, gravitational force is a conservative force. Now, kinetic energy. Kinetic energy is defined as the energy of a body due to its motion. That is, every moving body possesses kinetic energy. For example, a moving cricket ball possesses kinetic energy. Every moving part in this engine possesses kinetic energy. Formula for kinetic energy. Suppose a body of mass m moving with a velocity u is acted upon by a force F for time t. Let v be the final velocity and s be the displacement of the body at the end of the time t. The work done by the force in displacing the body is given by work done is equals to force into displacement. Work done is equals to F into S, that is equals to ma into s. We know that v square is equals to u square plus 2as. As is equals to half v square minus u square. Substituting as in first equation, w is equals to m into half v square minus u square. W is equals to half m into v square minus u square. This work done is possessed by the body in the form of kinetic energy. Therefore, Ke is equals to half mv square minus u square if the body is initially at rest and its final velocity v, then Ke is equals to half mv square. Note, kinetic energy is directly proportional to the mass of the body and is directly proportional to the square of the velocity of the body. If mass is doubled, kinetic energy is also doubled. And if the mass is halved, kinetic energy is also halved. If velocity is doubled, kinetic energy increases 4 times. And if the mass is halved, Kinetic energy reduces to one-fourth of the original value. Kinetic energy is always positive. Why? Since mass is always positive, even if the velocity is negative, square of the velocity will be positive. Therefore, kinetic energy is always positive. Kinetic energy is a scalar quantity. The term speed can be used in place of velocity in the formula for kinetic energy. What is power? Power is defined as the rate of doing work or consuming energy, or power is defined as the rate of conservation of one form of energy into another form of energy. Mathematically, power is equals to work done by time taken. P is equals to W by T, or P is equals to energy consumed by time taken. That implies P is equals to E by T. Power is a scalar quantity. SI unit of power is watt. 1 watt is equals to 1 joule per second. 1 watt is the power when 1 joule of work is done in 1 second, or 1 watt is the power when 1 joule of energy is consumed in 1 second. 1 kilowatt is equals to 1000 watts. 1 megawatt is equals to 10 to the power of 6 watts. 1 kilowatt is equals to 1000 watts. 1 megawatt is equals to 10 to the power of 6 watts. Another unit of power is called horsepower or HP. 1 HP is equals to 746 watts. The power of engines of cars and other vehicles is measured by unit called brake horsepower, which is equivalent to 1 horsepower. Commercial unit of energy. The commercial unit of energy or trade unit of energy is known as kilowatt hour. 1 kilowatt hour is the amount of electrical energy consumed when an electrical appliance having a power rating of 1 kilowatt is used for 1 hour. 1 kilowatt hour is equals to 1000 watts into 3600 seconds. That is equals to 3.6 into 10 to the power of 6 joules. Now, once again, rate of doing work is called power. Power is rate of doing work. If W is the work done in time T, then power is equals to work done by time taken. P is equals to W by T. The unit of power is watt. 1 watt is the power of an agent which does work at the rate of 1 joule per second. 1 watt is equals to 1 joule per second, or 1 watt is equals to 1 joule second inverse. 1 kilowatt is equals to 1000 watts, or 1000 joules per second, or 1000 joules seconds inverse. Commercial unit of power. The commercial unit of energy is kilowatt hour. 1 kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt, that is 1000 joules per second. 1 kilowatt hour is equals to 1 kilowatt into 1 hour, that is 1000 watts into 1 hour. 1000 watts into 3600 seconds, that implies 3.6 into 10 to the power of minus 6 joules. The electrical energy used in homes and industries are expressed in kilowatt hours. The electrical energy used during a month is expressed in units. Here, 1 unit means 1 kilowatt hour. Transformation of energy. The change of one form of energy into another form of energy is known as transformation of energy. Different examples are given. The device, energy in first form, energy in second form, and energy in the third and fourth forms. A body is thrown upwards, kinetic energy, first form, then potential energy. A body is dropped from a height above the surface of the earth. First is potential energy converted into kinetic energy. Sound, light, heat. If the body is stone or heavy metal falling on the hard surface. Filament bulb. Electrical energy is converted into heat energy and then into light energy. electric iron. Electric energy is converted into heat energy, also light energy, if an indicator is fixed. The device is thermoelectric power. Chemical energy of coal is converted into heat energy, then into kinetic energy, and then into electric energy. Then hydroelectric power station. Potential energy of stored water in the dam is converted into kinetic energy, then into electrical energy. Nuclear power station. Nuclear energy is converted into heat energy, then into kinetic energy, then into electrical energy. Windmill of electricity. The kinetic energy of wind is converted into electrical energy. Microphone. The sound energy is converted into electrical energy. Loudspeaker. Electrical energy is converted into sound energy. Gas stove, chemical energy of LPG is converted into heat and light energy. Law of conservation of energy. Law of conservation of energy states that energy can neither be created nor destroyed. Whenever energy changes from one form into another, the total amount of energy retains constant. When a body is thrown upwards or dropped from a height, the total mechanical energy, that is sum of potential and kinetic energy, at each and every point on its path remains constant. Note that at the highest point of its motion, the energy is fully in the form of potential energy, and at the lowest point, the energy is fully in the form of kinetic energy. At all other points, the energy is partially potential and partially kinetic. Potential energy is maximum and kinetic energy is zero at the extreme positions, whereas kinetic energy is maximum and potential energy is minimum at the mean position of a simple pendulum.